So in this lesson, we are going to talk about change in linear momentum of an object. Previously, we said momentum is the product of mass and the velocity of an object. The formula for calculating momentum is P equals to mv. We said the SI unit for momentum is kilograms meters per second. Again, we said momentum is a vector quantity. It has both magnitude and the direction. So we said there are two physical quantities that defines momentum, and those physical quantities are mass and the velocity of an object. We said momentum depends on mass and the velocity of an object. We said there is a relationship that exists between mass and the velocity of an object as well as its momentum. So I have this truck here. Is it moving? Definitely it's not moving. Okay, can you think of any reasons of why is it not moving? Okay, one of the reasons why this truck is not moving is because it does not have what you call the velocity. And if it does not have the velocity, its momentum will be zero. Remember, if you change the velocity, the momentum of the object will change. When you change the mass of the object, its momentum will change as well. But in this case, we are only going to look at the relationship between momentum of the object and the velocity of that particular object. Why? Because when we investigate the relationship between two variables, one of the variables must be kept constant. And what will be that variable? In this case, mass will be kept constant. So hence, the topic of today is change in linear momentum. So what determines this change in linear momentum of an object? In this case is the velocity. So when we change the velocity, the momentum of the object will change. Let's go back to our track scenario. So this truck is not moving because it does not have velocity, and its momentum, of course, will be zero, since there is a direct relationship between the momentum of an object and its velocity as well as mass. But keep it in mind that mass is going to be kept constant because we want to understand the relationship between momentum and the velocity of the object. Besides the velocity, again, the engine of this truck must have power so that it can be able to move this truck from one place to another. So the formula for calculating power is given by P equals to work divided by change in time. Hence, the definition of power is the rate at which work is done, or work done per unit time. Then you're talking about power. Then how do we calculate work? So work, which is W, equals to force multiplied by the distance that the object has traveled, divide by change in time. So therefore this means power equals to force multiplied by the distance, which is work, over change in time. So now we have introduced another concept or another physical quantity that can affect change in momentum of an object, and that particular physical quantity is force. There is the relationship between momentum and Newton's first law as well as Newton's second law. Okay, so let's start with Newton's first law. I'm just going to use simple terms to explain it. You can go to your textbook and get the actual definition of Newton's first law, because remember, in your curricula they have a way of explaining things or wanting you to know things in particular way. So Newton's first law, it says an object will remain on its state of rest, not moving, or it will continue to move with its constant velocity, or it will continue with its constant motion until there is a force applied on it. Okay, so now let's see here. This truck, it is at stationary position, or it is in stationary position rather. So it will only move from one place to another if the engine apply force, or if we push this truck from point A to point B. That's what Newton's first law means. So now, what is the relationship between Newton's first law and the momentum? So now this truck is at its rest position, the velocity is 0. This object, it will have 0 momentum until we apply force on it, or until the engine applies force so that it can move from one place to another. All right, so if I apply force on this truck, it will move from one place to another, hence its momentum will change from 0 to a particular value in terms of kilograms meters per second. Secondly, this truck will continue to move with constant velocity, or will continue with its uniform motion, hence its momentum will be constant until I apply force on it. Then its momentum will change. That's Newton's first law and how it is related to momentum. So Newton's first law explains the effect of force on the current state of the objects. If the object is in stationary state or rest position, it will only change its state if force is applied on it. Or when the object is in constant motion state and we apply force on it, it will eventually stop, which means its state, what state? Motion or constant motion state will change because we have applied the force. So you can see that Newton's first law actually explains how or what are the effects of force on the current states of the objects. Newton's second law, it explains how this force from Newton's first law is related to mass and the acceleration. What is the relationship between change in linear momentum and Newton's second law? So let's say this truck is moving with velocity, and that velocity is going to be v initial, vi. Let's calculate its momentum. Let's state our directions. So we are going to say to the left we are talking about negative direction, and to the right positive direction. Second step, we are going to list our data. So the mass of the truck equals to m kilograms. Velocity of the truck is going to be negative vi. Remember, velocity is a vector quantity. It has both magnitude and the direction. So this negative indicates that our truck is actually moving towards left, towards negative direction. So our velocity is going to be negative vi meters per second, and our momentum, which is p, we don't know. the momentum. So third step, we write down the momentum formula. P equals to M multiplied by V. So now we are going to substitute our variables. So our mass is M, mass M, multiplied by our velocity is negative VI. So our momentum is going to be minus mvi, kilograms meters per second. So now if you check here, our momentum is negative y because momentum is a vector quantity. It has both magnitude and the direction. So this indicates that the momentum of the truck is mvi to the left. So now we need to state this direction in words. So we are going to say, therefore, our momentum equals to mvi kilograms meters per second to the left. So our truck has finally stopped. Now we are required to calculate its momentum before it came to its rest position or stationary point. So we have to calculate its momentum in terms of M and VF because it has finally stopped. So we have to calculate its momentum just before it stopped. Firstly, let's state our directions. So to the left, you're talking about negative direction, and to the right, positive direction. Secondly, let's list our data. So mass of the truck equals to mkg. Velocity of the truck is negative vf, because remember they said calculate the momentum of the truck in terms of m and vf. So obviously we are looking for the momentum of the truck. So that step, we write our momentum formula. P equals to mv. Then we put our values. In this case, we have variables. So mass equals to m multiplied by our velocity is minus vf. So our momentum will be, or the momentum of the truck will be minus m vf kilograms meters per second. So we are going to state our direction in words, because now you see that we have negative momentum. This negative indicates the direction. So the momentum of the truck equals to mvi kilograms meters per second to the left. When we are stating our directions in words, we ignore the signs. Firstly, the momentum of the truck was mvi kilograms meters per second, and finally the momentum of the truck was mvf kilograms meters per second. Okay, of course, to the left, okay. So you can see that the truck's momentum changed because the velocity changed. Why am I saying the velocity has changed? Is because on our first momentum we have VI. Now second momentum we have VF, or final momentum we have VF. So these velocities are not the same in terms of variables. If they were the same, here we will have VI and VI here as well. So we have VI and VF. Our variables are different, hence the momentum or the momenta, that's the plural of momentum, the momenta of the truck will change. Since the momentum of the truck has changed, this means we can calculate change in momentum or change in linear momentum of the truck. So how are we going to do that? Remember, change in science, even in mathematics, is defined by this simple delta. So change in momentum will be delta P. Okay, what do they mean by change? When we want to calculate change of a particular physical quantity, it will be that particular physical quantity final, or the value of that particular quantity final, subtracted by the value of that particular physical quantity initial. So what do I mean? I mean that change in momentum will be momentum final minus momentum initial. What is the final momentum of this truck? The final momentum of this truck is mvf. It's written here, mvf minus what is the initial momentum of this truck is mvi. Okay, so here we can take out common factor as m, because m appears in both terms. So m into vf minus vi. This indicates change in velocity because is velocity final minus velocity initial. So this means we can say m multiplied by change in velocity. So our momentum, our change in momentum equals to m change in v. So this will be the formula for calculating change in momentum of the truck, or this will be change in momentum of the truck. Now let's see how change in momentum of an object is now related to Newton's second law. So we know that Newton's second law is defined by this formula, F net equals to mass multiplied by the acceleration. We know that acceleration equals to change in velocity over change in time. Hence, the definition of acceleration is the rate of change in the velocity of an object, or change in the velocity of an object per unit time, and the SI unit for the acceleration is meters per second squared. Okay, so we are going to substitute this acceleration here with this expression. So this means F net will be equal to mass. Where we see acceleration, then we substitute it by this expression. So it's going to be change in velocity over change in time. All right. So now you can see that mass multiplied by change in velocity drives us back to change in momentum. So this means we can substitute this and with a change in P. So it's going to be F net equals to, okay, force is a vector, change in momentum, because this is change in momentum over change in time. So therefore we have our new formula for calculating F net or net force. So F net equals to change in momentum over change in time. So this is how Newton's second law is related to change in linear momentum of an object. Hence, from this formula, we can come up with a new definition for F net. We can say net force equals to the rate of change in momentum of an object. So this is how you can define F net. So from this formula, we can go further and multiply both sides by our change in time. Let's see, what do we get? So we multiply both sides by change in time over 1 multiply by change in time over 1. So this and this will cancel each other out. So you are going to have F net multiplied by change in time equals to change in momentum. So we have another formula now, and this formula is for calculating the impulse of an object. Okay, so when they say define the impulse, you can derive the definition from this formula. You can say impulse equals to change in momentum of an object, or the product of net force and time. We get the impulse. So in this video we said, of course, we have momentum, which is given by P equals to mass multiplied by the velocity, and we said the momentum of an object will change when we change the velocity or when we apply the force on that particular object. So when we change the velocity or apply the force on the object, we'll have what we call change in momentum, which is represented by delta P. How do we calculate change in momentum? Change in momentum equals to mass multiplied by change in velocity. You change the velocity, you change the momentum. You apply force, the velocity will change, hence the momentum will change also. We said there is a relationship between change in momentum and Newton's second law, and that relationship will result into F net equals to change in momentum all over change in time. Then we said from this formula we can come up with the new definition of defining net force. We can say net force is the rate of change in momentum of an object, or change in momentum of an object per unit time. Then if we multiply both sides by change in time, we get what we call an impulse. And this is the formula for calculating impulse. So the definition for impulse will be change in momentum of an object is impulse. And so you can see that there is a link between these formulae. So we can say from this formula of momentum to this formula of momentum, you have to change the velocity, or you need to apply force on an object, right? And from this formula to this formula, how are they related? This is Newton's second law. Newton's second law, right? Then when you multiply both sides, by change in time, you get the impulse. So this is the relationship between this I can say 4 formulae. Okay,